I tried recording this at home, but I can't because I have a 1-month-old baby, and she just did not want us to record, so she was just screaming, and you couldn't hear anything. So I've done this experiment with second graders. It can be done with high school students. The experiment is on erosion, and the way we do it is you have 3 different models. Your first, and each one of these buckets, or tins I guess, has sand, and they're set up in different ways. So the first one is set up like a mountain. The second one is flat, like the sand is flat, like a beach. And the third one is just like the first one, like a mountain, but it has a piece of tissue on top. For the experiment, what we're studying is the effects of erosion on the Earth. So to do it, you set up these cups, which have holes in them, and then you take the water and you pour it on, and you see the effect. You know, I mean, I don't have like the perfect amount in each one of these, but I guess you would want to keep, if you wanted to keep it a control, you'd want to do the same amount of water for each, the same amount of sand for each. So what you would do is you would make a hypothesis as to what would happen. So does anyone have any ideas with the first one? It's just a pile of sand. Does anyone have any idea what might happen if you pour water on it?
Flatten out.
It might flatten out, okay. What about the one that's flat? Make a crater or a river, or flatten faster, even more flat. What about the one with the tissue paper on top? The slowest, yeah. So what you would do then is, of course, pour the water and see what would happen. I'd like to try and pour a whole cup. I know it's hard, you guys can't really see from over there. If you guys wanted to come, you can. So pretty much exactly what you guys said would happen. I mean, you guys are adults, so you should know some of this stuff. But a hole is created in the first one. The second one, it pretty much just engulfs the whole thing, just because the sand is already flat, so it just, like the water level basically rises. While the third one, it pretty much holds its shape completely and doesn't really move at all. It sinks a little bit, but it doesn't really change at all. It just gets heavier. Does anyone know what the tissue would represent? For my second graders, I make it green, if that helps in any way. Grass or any kind of forest, any kind of green that can actually, bushes, anything like that, helps erosion. And so, like I said, so with second graders, I would keep it very simple like this, draw a picture of what you're predicting, and then maybe draw a picture of your results, which one worked the best, and then they would say A, B, or C. In high school, you can really spiral it up to like how does this relate to erosion, in our lives? With climate change, you could, refer to like Sandy and be like, all right, so like a lot of the beaches now have eroded. What's one way that we can prevent that in the future? Well, maybe if we planted more plants and bushes in these places, they might slow the erosion. I'm like, yeah, exactly. So then they get it. So it's nice because you can really, even if you're at the high school level and you have a kid with special needs, you can spiral it down even. So it's a nice open concept. It's an experiment you can do at any level. And I've done it before in middle school and in second grade. So that's it.